welcome everyone, and thanks for coming on to my talk. Look out, gotchas of using threads in Ruby. And I feel like Matt's keynote was amazing, and I was looking at the keynote and I was thinking, Matt's keynote is either the best keynote to have before my talk or the worst, because Matt touched on a bunch of things I'm going to talk about too. So hopefully it's the best thing to have before my talk. So let me get started. So who am I to be talking about to you about this here? So my name is ANJO, and I'm a senior software engineer at Datadog. And I've been using Ruby since 2014, and ever since I started using it, I fell in love with it. I like the expressibility, the community, the tools. Like, it's just amazing to use Ruby. So I've always liked using Ruby. And I've always also enjoyed like exploring language runtime. So I've explored a bit C Ruby, J Ruby, Truffle Ruby, the Java VM, etc. So it's something I really enjoy doing. And I still have my Euruko 2017 t-shirt, but it's a bit old now, so I use it as a pajama now. I also enjoy playing with concurrency, which is where like a lot of the things from this talk came from. And I also really enjoy working on application performance, and specifically on building tools that by let you look at the performance in a new way and help you uncover new insights on performance. So that is how I ended up working on this thing. This thing is the Datadog Continuous Profiler for Ruby, which I am the person building it at Datadog. Also here today is Gustavo, my colleague that works on application security management. So if you want to talk a bit about security, you can talk to Gustavo as well. OK, so a bit of an outline. We'll talk a bit about why you should learn and why is it interesting to learn concurrency. Then a bit about concurrency in Ruby and threads, which are one kind of concurrency that Ruby offers. Then a few gotchas using threads. Then we'll discuss a bit about what is atomic and not atomic code. Then a few examples of things that you might think should be atomic, but actually aren't. And then we'll finish with a bit of a recap. So let's talk about concurrency. Concurrency is not dark magic, and I feel like a lot of times people kind of shy away from it or are a bit afraid of it because it seems like this thing that only like really experienced wizards in Ruby can use, and it's not true. Concurrency is actually a really powerful and useful tool that you can use to solve a lot of problems in your application. So it's really worth having this tool in your toolkit rather than saying, I shall not go there. And you can have fun with concurrency without like being this mega wizard that knows a lot about concurrency, etc. And so one thing you should be careful about concurrency is like the famous like superhero thing, like with great power comes great responsibility. So sometimes you're using concurrency, and well, concurrency there has a few pitfalls, a few challenges, so you need to be careful. And also, but there are a lot of problems that you can solve really well with it. So don't shy away from using it if it's the thing to solve your problem. So don't treat concurrency as something you'll never get. You can learn it. It's like a skill, and you can learn to think about this. And the whole point of this talk is that by talking through a few like things that, oh, whoops, that I've run into, and a lot of the gotchas I have for you today are actually things I've run into in production, either myself or like at companies I've worked at. By looking at these gotchas and understanding why they happened and how we can fix it, you can kind of improve your mental model of what to expect when using concurrency. OK, so let's talk concurrency in Ruby. Concurrency in Ruby has never been in better shape. Nowadays, we have processes, we have reactors, we have threads, we have fibers. And all of these are in like continuous improvement. So people are working to lower the memory usage, make them more efficient, make them faster, make you be able to create more of these with lower overhead. So concurrency in Ruby is in really great shape on the latest Rubies and the upcoming ones. And if you ever thought about this a bit, you can actually notice that they form a hierarchy. So inside the Ruby process, you can have multiple ones, but inside one process, you can have one or more reactors. And if you're using on Ruby 3 and you're not explicitly using reactors, this just means that you're using the main reactor, which is the one that Ruby automatically creates for you when you start a Ruby app. So reactors, one or more inside the process. And the same thing happens with threads. You can have one or more threads inside each reactor. And again, if you're not explicitly creating a thread, you're just using the default thread that gets created inside the default reactor in your Ruby process. And the same thing happens with fibers. So in Ruby, fibers are tied to specific threads, and you can have one or more fibers inside the thread. And again, if you haven't created one explicitly, you just have the default. So let's compare them a bit. And in this talk, I'm mostly focusing on threads. So let me compare like threads to some of the others. So threads versus processes. So threads usually provide you with lower memory usage because they share the same set of memory. It means that you don't have to duplicate stuff in memory. So when you have multiple processes, you often end up duplicating memory. Or even, for instance, if you have YJIT will compile stuff. And so often, if you have multiple processes, YJIT will have to be inside those processes and compiling stuff again. Whereas with threads, you can share stuff. And so you get like easy communication, easy cooperation, etc. But threads do offer a lot less isolation than processes. So for instance, if something goes wrong in a web request that's only inside the process, you can just kill the whole process, and that's fine. You know, no more impact. It's over. Whereas like if something goes wrong in a thread and you have multiple threads, even if you kill the thread may have left the rest of the system in some wrong or inconsistent state, so a lot less isolation. As well as latency impact. So when you have multiple threads on your application, they can impact each other's like latencies, whereas with processes, technically you can because, well, they're still inside the same machine or container, but usually the operating system will do a lot better job in terms of like making sure everyone gets the time they want, versus when you have threads in Ruby. Okay, threads versus reactors. So to be fair, reactors are still experimental, so threads aren't. And threads allow you to share mutable objects. And I will cheat a bit because I'm marking it as an advantage, but sharing mutable objects is also a disadvantage. So a lot of problems you can have with threads and concurrency is from like threads are really powerful and allow you to do this kind of sharing. And reactor is a much limited model, and by being more limited, it kind of takes away of some of the foot guns that you might have. And so it's both an advantage and a disadvantage that you can share stuff. Reactors are a lot more isolated because that's exactly the point. They can communicate in much more restricted ways. And threads share the same global VM lock, or JVL, which we've seen Matt talk about a lot here today. And I'll talk a bit more during this presentation. Finally, threads versus fibers. So threads employ what we call preemptive scheduling, and fibers use cooperative scheduling. So these big words, what they mean is that if you have multiple threads, Ruby will automatically switch between threads. So this is what we mean by preemptive. Whereas in fibers, Ruby usually, and said unless you're using something like the fiber scheduler or something like that, you have to manually switch between threads. Which means you can have a bit of a latency impact, because if a fiber never switches to another fiber, there can be seconds, minutes, hours, days, where other fibers are waiting to execute, and if one fiber doesn't switch to the next one, they will not run. Whereas with preemptive scheduling, at some point Ruby will say, wait, it's not your turn anymore, the other thread gets to run. So again, preemptive scheduling and cooperative scheduling is something that makes it, it's more powerful, but makes it sometimes harder, so advantage and disadvantage. And threads are way more expensive to create and require a lot more memory. So usually we'll have like dozens or maybe hundreds. And if you're getting into hundreds of threads in your application, you're probably already like stretching the limits, and you will find like Ruby and your operating system will start not behaving very well. Whereas like with fibers, you can have many more, and they're much cheaper to create, much cheaper to have in memory, etc. So yes. Okay, so let's talk about some of the gotchas of using threads and what can we learn from them. So, gotcha number one. Threads in Ruby are concurrent, but they are not parallel. And the asterisk there we'll talk about in a bit, but let's see what we mean by this. So, concurrency versus parallelism. Let's say that we have some method that does some math, or maybe just encodes a really large JSON object or something, and that takes 5 seconds. Well, if we execute it twice in a row, that will take 10 seconds. Fine. And in Ruby, if we create two different threads and we ask both threads to work to call the same method, it will still take 10 seconds to run both of them. So this is a key insight, is that when you have thread number 1, and if you imagine like it goes, time goes along the x-axis, what happens if you start another thread that's also running some things on CPU is that Ruby will kind of, and this takes 5 seconds, yeah, and Ruby will kind of split stuff. And then the idea is that you have two threads, and Ruby will kind of like go back and forth, back and forth, back and forth, back and forth. And at the end of this, it will kind of take 10 seconds, because it's the same amount of work, but Ruby will just kind of switch back and forth. So insight is that things don't run exactly at the same time when you're using multiple threads in Ruby. Ruby is just switching back and forth between threads. And this means that code execution doesn't go faster with multiple threads. So if you have something that is just like some work, you're just going through a bunch of objects, doing some operations, creating objects, freeing objects, etc. This doesn't go faster with multiple threads on Ruby. But it does mean a bit what Matt was saying. If you're wanting to run a multiple database queries, you're just running multiple web requests, that means that you're often not on CPU. You do a bit of work, and then you go to the database. And while one thread is going to the database, Ruby can say, oh, the other thread can run, and the other thread can run, and so on and so forth. So this is why threads are still extremely useful in Ruby, and we've seen examples of it during Euruko. And also, one thing to be careful about is that using multiple threads can add latency to your application. And actually, I've created a gem called JVL Tracing, and Shopify also created a gem called JVL Tools that can help you diagnose this. So especially if you're mixing like a thread that does a lot of work on CPU and like a thread that doesn't do much work on CPU, like you can have a lot of impact in terms of the time that it takes to do it all. Okay, so let's go on to gotcha number 2. Gotcha number 2 is that threads in JRuby and Truffle Ruby and reactors in FreeRuby are actually parallel. So what this means is that if we have our example again, some math that takes 5 seconds, and we run it on two different threads, on JRuby and Truffle Ruby, it actually takes 5 seconds. So it actually goes faster. Assuming, of course, you're on a multi-core machine, but if you have any CPU that was manufactured in the past 15 years, you have multiple cores. And the same thing happens in Ruby, CRuby. If you create two reactors and you execute some code on them, it will take 5 seconds as well. So as a bit of a comparison, the idea is that you have one thread, this thread takes 5 seconds, you add another one, this takes 5 seconds, same thing with reactors, and all of this takes 5 seconds. So it's actually a big difference between JRuby and Truffle Ruby and regular CRuby is that threads are parallel on this. But reactors in Ruby offer the same kind of thing. Okay, some insights on this. It's possible to get parallelism in Ruby, so don't let anyone tell you otherwise. And also with processes. So for a long time, like people have been doing parallelism in Ruby using multiple processes, using like web servers like Puma configured in multi-process mode or Unicorn or etc. So it's a great way to get parallelism in Ruby. Okay, gotcha number 3. When you're using threads and sleeps in your tests, you can write what ends up being flaky tests. So for an example, assume that there's some result, and in your test you create some background thread, or indirectly some background thread gets created to work on that result. And then you're like, I'm not entirely sure when the result is done, so I'm just going to do this. I'm just adding a slip here, and it works on my machine, so expect result to equal something. It's fine, I'm super happy, it works. And then what happens is that maybe you like move on to a new machine, and on your new machine, this test starts failing sometimes. And then you go like, oh yeah, 0.1, maybe I'll slip for 200 milliseconds instead of just 100. And this works, and it's nice. And then you go like, oh, you push it to CI, and then CI is like, oh yeah, it fails sometimes, and you go like, okay, half a second, okay, it's a shame, but let's move on, it's fixed. And then you get a new colleague, and this new colleague actually is like me, he uses like Linux, and he uses like some weird container within container within container to run stuff, and it doesn't work for him, it fails sometimes. And then you go like, okay, 10, I'm tired of this crap. And then at some point, like CI is having a bad day and 10 is not enough, and you go like, oh, I'm tired of this. Like, what the hell? And this is like something you should be careful about, is that you don't know when Ruby is kind of going to switch threads, and you don't know how much time something is going to take to run. So you should avoid relying on this. And so in a sleep, you're like implicitly, when you do sleep 0.1, it's a bit like the why. Like, why are you doing sleep 0.1? Well, because you kind of know that Ruby will switch to the other thread, and that thread will probably be able to do the work it needs in that time. But you're not sure. So it's not a good idea to rely on this, because you get flaky tests. And not just flaky tests, but in general, like flaky problems in your code. Okay, so how can we fix this? One solution is wait for the thread to finish. So in very simple examples, you may be able to just call join. And if you call join, you're basically saying to Ruby, well, stop my thread until the other thread is done. And then you don't need a sleep, and it works. So this is a very simple example. But on a more generic case, you might not be able to know when the other thread finishes, because maybe it's inside some framework, or the thread, you don't control the lifetime of the thread, or it's like a thread pool, or maybe you just want something to happen in the middle of the thread, not at the end, or something like that. So a more generic solution is to use the queue class in Ruby. And you can use this queue class to communicate very easily across threads. So in this example, we create like this done queue. And what we do is, when we create the thread, we at some point say, like, put something on the queue. It can be as simple as a symbol saying done. And then you don't need the sleep, and you just wait. You use the pop function to wait for something to come in the queue. And when that something is done, you know that that thing is finished. And I've used like even more complex versions. You can use like 2 queues to communicate across threads. So if you want one thread to say, I'm done with something, and then the other thread can start working, and then can say, I'm done with something as well, and then the other one can be, okay, I can continue. So you can use like 1 or more queues to coordinate across multiple threads, so it's a really powerful thing, and it works really well. So because like thread queue and thread size queue, they are both built for safe concurrency in Ruby, so they're really easy to use. Okay. Another way of fixing this that is kind of like I've used sometimes is what I call the a better sleep solution, which is that instead of using sleep, you can use this wait for thing that rspec wait gem provides, or even build your own. So the idea of something like this is, instead of choosing like a specific time for sleep, and then you have to, if you sleep too much, then your tests are slow. If you sleep too little, your tests are very flaky. You can just like sleep a bit, then check the condition, then sleep a bit, then check the condition. So you basically use sleep with a loop, and then you kind of go back and forth. And that, in some cases, when you have to deal with things in concurrency, that can be a solution that gives you reasonable tests and reasonable, not flaky, although some of the other solutions can be better. Okay. Gotcha number 4. Let's talk about hashes. Let's say if we have a hash, and then we have a thread that's just like writing stuff to this hash. Fine. And then we create another thread that's just kind of going through stuff in the hash and trying to call some method on it. Fine. What happens when we run this in production? From time to time, because you never know if both threads are going to run, when they are going to run. Well, from time to time, you get this thing. Can't add a new key into hash during iteration. Runtime error. You get this exception in Ruby. And the problem that's happening here is that this thread is trying to add a new key into the hash, and this thread is trying to go over the elements. It's trying to go each map. A lot of operations in Ruby have to iterate the hash, and you can't do this. So it's obvious in this very minimal example. I've given you 7 lines, but it's really, really hard to debug this kind of problem in production. And I've seen it multiple times happening in production. And the problem is, it's really hard to answer this question. Who's iterating the hash and why? Because the exception that you saw there will happen on the writer. So the writer tries to write, and Ruby will say, exception, someone is iterating the hash. And then you go like, who? And Ruby is like, good luck. So you have this problem of maybe like feature request for Ruby. Ruby could kind of tell you like what's the other thread, who's iterating the hash, but it's really hard to find out, and you are on your own to figure this out. So avoid writing if you're sharing a hash between multiple threads. So how do we fix this one? Well, the easy version is maybe if you can afford to like do whatever you need to do on the hash and then freeze it and then share it, that's a really good solution. And furthermore, it makes it really easy to spot, like if you freeze most things after you're done with them, it makes it very easy to spot when you're writing to them after the fact and you didn't mean to, because maybe there's a bug and you actually thought you were not going to write, but you are. So it's much easier to spot because this exception happens every time. Whereas the exception I was showing you before, it happens when both threads are at the same time, but that maybe doesn't happen every day, or maybe it just happens once an hour. So that one is much harder to find, whereas this one, Ruby will tell you all the time. Solution number 2 is obviously if you can just create a copy instead of sharing, that's great. But these are like the easy ones. Like if you can get away with these ones, they are the best. Okay, let's go a bit deeper. So if you use the concurrent Ruby gem, which I recommend when you want to do like some of the more powerful concurrency stuff, you can actually require concurrent, and instead of the hash, you can use the concurrent map class. And if you do that, this works. Concurrent Ruby is built for concurrency, and this is one of the use cases for concurrent map. It's this, it works. Okay, so what about if you want to roll your own using a mutex? So a mutex is a tool that Ruby provides you so that you can basically enforce one at a time access to something. So the idea is that you have your hash, you create a mutex, and then when you want to write to the hash, you call mutex.synchronize and you pass in the write. When you want to read, you call mutex.synchronize. But it's kind of easy to forget to synchronize. So I usually recommend, if you're going to do this, just create a class that contains the hash and the mutex and kind of restricts the direct access to the hash, because otherwise it's easy to do it wrong. And this has a few other disadvantages. For instance, while the each is running, the other thread can wait for a long time. So there's a bunch of disadvantages of doing this, but here's an example of how you can use fine-grained locking to do this. Okay, so a few hints on this one. Avoid sharing to any shared object, not just hash. So in here, you might think, oh, Ruby kind of sucks. I really wanted to write to the hash while I was iterating it. And Ruby is like, no, you can't. And like, Ruby, why are you doing this? But actually, Ruby is being great. Ruby is saving you from a much worse bug. So in general, like, you should avoid writing like this to something that you're also reading, not just a hash, because Ruby doesn't throw this kind of exception on your code. Some issues can break only under production traffic. So this only happens if these two threads happen at the same time. But maybe if they happen like 1 second later, this issue doesn't happen. So it can be one of those bugs that happens sometimes. And specs and integration tests are often like too simple to catch some of these issues, because these threads may be different parts of your application. And when your unit tests, you might not run those two parts at the same time. Or even maybe if this is like 1 in 10,000, 1 in 10,000 in your specs is, well, that it's 10,000 times you're running RSpec. But 1 in 10,000 in production is every 5 minutes. So concurrent Ruby can be like a really good tool if you need to. Okay, let's talk a bit about atomic behavior. So what we mean by atomic? By atomic, we mean like some instruction or operation of piece of code that happens all at once or not at all. So it's atomic in the indivisible sense of the word. And this is a concept that shows up in like a bunch of tools. And for instance, like it's very used in database transactions. Like database transactions are atomic. And so it means you can read from a bunch of tables and write to a bunch of tables and then just say commit, and that is atomic. And other transactions cannot observe like the middle of you're doing these operations. And so why am I telling you this? I am telling you this because when you share objects between threads, they can actually observe other threads in the middle of changing them. So most operations in Ruby are not atomic. So now that you know what atomic is, I'm here to tell you most things in Ruby are not atomic. And this might be surprising to you, but Ruby can switch threads at almost any time, including in the middle of the method or in the middle of a line. So you can, if you write something like to a variable and then something to another variable in the same method, it's possible for a different thread to not observe that thing and observe only half of it. So this is actually something that you need to be on the lookout for. So let me give you an example. So in this bit of code, I have from and I have to. And the idea of this code is that one by one, it will decrement from, and then it will add one to two. And you can see the loop going over it. And I just added 50 threads on it to kind of make it more interesting. And when I run this on this machine a few months ago, I ran it and I got this result. So at the end of running the code, I had 11 more elements than I started with on the 2. So why does this happen? This happens exactly because of this issue of Ruby switching threads. So let me give you an explicit example. Consider that we're on the last iteration. So from is now 1, and 2 is like 99,99999, and we have one more to go. So if we have one thread, and oh, time flows from top to bottom. And if you have one thread, well, this thread reads from, and it's 1, and so it says, okay, it's bigger than 0, so I'm going to go inside the loop. So now we read it again, and we subtract from it, and we write back 0, that's fine. And then we read 2, it's 9999, we add 1 to it, we write it back, and fine, worked, amazing. Okay, let's add a second thread. And now let's say like this thread reads 1, and then goes inside the loop, and then Ruby decides, let's switch over to the thread number 2. And then this thread will read from, and will also get 1. So now the second thread will also decide to go into the loop. And this is already weird, right? Because we had one more iteration to go, but 2 threads have decided, oh yeah, I'm going to execute this. This is fine. Okay, so let's say that Ruby switches back and forth. Ruby will switch back from to thread 1, and thread 1 will read from. It's still 1, and switches to thread 2, and what will thread 2 read? Well, the same thing. It's still 1. So now thread 1 will write 0, so it will decrement, take 1 from what it read and write it back. And what does thread 2 do? Well, thread 2 read 1 as well, so it decrements 1 from it and writes 0. But you can already tell, like, something weird happened here, right? Like, one thread wrote something and the other wrote something on top of it. So, like, okay, it's still, okay, we got lucky, but it's weird. Okay, let's go on. Now this thread reads 2. Now thread number 2 reads 2, and then thread number 1 writes back 1 more. And thread number 2, well, it read 9999, adds 1. What will it write back? The same thing. So, yay, we got the right result. But you can tell that we got the right result in a really weird way, right? Like, something was wrong here. Okay, let's make this more interesting. Let's go again and add a third thread. And now let's say thread 1 and 2 will do the same, and thread 3 is the interesting one. So reads, let's go inside the loop, and then thread number 3 also reads. Okay, 3 threads are inside the loop. Amazing. Okay, this reads, and now thread number 3 doesn't actually run. Ruby decides, okay, I'll just go back to thread number 1. And thread number 1 subtracts the value, writes it back. Thread number 2 subtracts the value, writes it back, same as before. And now thread number 3, Ruby is like, yes, let's go, thread number 3. And it reads 0 because, well, it's been written. So now what does it do? Well, it subtracts 1 and writes it back. So now from is now -1. And if you were looking at the code before using threads, like, this was impossible. Like, right? You do while from bigger than 0, you subtract 1 from it. It's never supposed to go below 0, but now it went. And if you go back, now go back to thread 1, reads 2, thread 2 reads 2. This thread doesn't run again. It's slow for some reason. And then you write back 2, and then what happens? Well, this thread wakes up and reads 2 is 100,000, and well, what should it do? It will add 1 to it, and here's how we get the 11 elements that showed up when I run this code on my machine. Like in this case, I got 1 more, but you can see how this happened. So some insights from it. Ruby doesn't usually change between threads on every line like I was doing, but it can change on almost any line. So like when I run it on my machine, it clearly, at some point, it changed and caused this problem. We call this, as Matt was saying, Heisenbugs, which are bugs that like only show up sometimes and can even be hard to observe, because if you start adding some logs to try to debug this, like the bug can go away because Ruby will switch threads at a different time, because when you write a log, you're doing IO, and so Ruby's like, oh, IO, let me switch threads. So like it can actually, like if you add a log, this can actually go away, the bug. So it's really hard to find. And I actually, I needed to set this to a really high value and to a lot of threads because, well, this doesn't happen always. So I needed to use lots of threads, lots of, go a lot of times around the loop to make this happen on my machine. So this is the problem. Like if in staging or in your testing environment, if you're testing with small amount of work, the issue might never show up. Obviously, this problem is only when you're writing to shared objects and variables, which in general, you should avoid it, and it eliminates the problem entirely. But I'm talking about this to give you a bit of an example of how you should think about this. Okay, surprisingly not atomic stuff. So there's a few things that in Ruby you might think, surely this should maybe be atomic, and it's actually not. So number 5, when you do this, well, you have some database client or something, and you create it with or equals. Okay, looks fine. And then here's the implementation for a new client. Well, I slip instead of connecting, but let's say it's an old slow server, so it takes a bit. And then I'll print just to make sure that we've created a database client, and I return a dummy symbol as a client. Okay, so what happens if I run this with multiple threads? Well, if I do this and I run it, I will get 1, 2, 3, 4, 5 instances of my database client, because the or equals is actually not atomic. And so you might have thought about it oh, the first one gets there and then initializes it and then it will get reused. But no, all 5 threads decided to create this. And I've actually hunted down this bug in production on a database client, exactly like this. And that database client then kept a bunch of connections and a bunch of background threads. And so we were like, why is our database complaining that it has too many open connections? Where are these connections coming from? Whoops, a bug in the code. And so it might not be even a database client. Maybe it's some background job getting queued, some email being sent, some remote API or some cloud provider clients that you're using, some microservice that you're calling. So this can be a big issue. So how can we fix it? Well, as a bad example, you could add a mutex, but you shouldn't do it like this because if every thread should use the same mutex. So make sure when you're using a mutex, you don't create the mutex every thread needs to use the same mutex object. The mutex object is built for concurrency, so it's one that you can share, and you should and you must share for this to work. So this is wrong. Let's try it again. Second attempt. Okay, we create the mutex, we store it in a constant, and all threads use the same mutex, and you do it like this. But this is wrong because you're still not putting the or equals inside the mutex. And what happens in this case is that all 5 threads will decide, oh yeah, we all need to create the client, and they're all going to try to acquire the mutex, and they will do so one by one. So let's fix this. You need to put the mutex around the or equals. And be careful about trying to optimize this. Some people actually try to optimize this further. There are tricks to optimize this further that may or may not work in Ruby, but be very careful about trying to optimize stuff because, again, it's hard to test this out. Concurrency is something that you run on you. If you just write a simple test and it passes, it doesn't mean it's correct. It just means that it worked for you on your machine with the way that Ruby switched threads at the time. Okay, some insights from it. Or equals is not atomic. Be careful when being concurrent and lazy, but in many cases it can still be fine. And make sure the mutex protects the right thing, and make sure you don't make the mutex initialization buggy as well. And I've seen some cases where people also kind of tend to use or equals or something similar for the mutex, so you're basically creating the same problem again. Okay, number 6. If you have some worker class that creates some arguments and then stores those arguments as states, and then at the end does some computation and then returns the value. And let's say that the sum domain logic here, I'm just using a sleep. And if you use one worker object and you use it for 2 threads, and let's say you call with different arguments. So on the first one, the result should be 3 because it's 1 plus 2. And the second one, the result should be 7 because it's 3 plus 4. Well, if you have something like this, you can have this problem, which is both threads are using the same objects and they kind of write over each other. So in this case, well, the first one won, so both got 3. And in this case, the second one won, so both got 7. So insights, don't share objects that keep intermediate states because threads will write over each other. And objects are not expensive, so be careful about over-optimization in like a context such as concurrency. So obviously, you don't, if you can avoid creating some objects in general, that's a good idea. But don't try to micro-optimize stuff around concurrency because you can run into issues. And yes, production and really bad, like data from multiple customers joining, not good. Okay. Number 7, and last one. Let's say we have an hello method, and then we have a slip here. And you might not know, but like when you're defining a class, it's actually Ruby code that's running. So you can put slip there, you can put the puts there, you can put anything. So here I'm putting a slip, and there's like a by. And requiring and defining a class is actually not atomic. So if you create a background thread that is requiring that file, and then in this thread, you're creating a new instance of the class, and then you're calling hello and bye, you can actually have this problem, which is you can run hello, but before bye gets defined, the first thread has to call bye, and then it doesn't work. And so you get this really bizarre error of undefined method bye, but if you, if you're looking at the code, you're like, bye is there. Why is not bye? Like, why is my instance not having bye? It's there. But like you can get this problem. So TLDR, be careful when you're like lazy loading and on-demand loading classes and gems after the application has started working, because in some cases you can run into this problem. Okay, let's recap what we've learned today. Ruby can switch threads at any time, so you should take this into account when you're writing concurrent code. If you're not sharing anything, you don't care. If you're sharing some things, you need to be to also remember like Ruby will switch threads, so I need to be careful about how I think about this. If possible, avoid having threads share and change objects or variables, but if you need it, there's tool for you. And Ruby already ships a number of useful tools, so we've seen today mutex, queue. Sized queue is like the cousin of queue, is just like a queue with a limit. And then freeze, it's amazing. Ruby also has a bunch more, like it has the monitor, which is like the mutex's cousin, but it's reentrant. And if you know what that means, then you know what that means. If you don't know what that means, monitor is not for you. You have condition variable, and you also have like fiber local and thread local tools, which are really useful sometimes when you want to have something per thread. Okay, concurrent Ruby gem is great. It offers like thread pools, atomic classes, so you have like the map that's concurrent. You have like atomic integer, it's actually atomic fixedom that actually allows you to count up and down without issues, etc. And concurrent Ruby is also cool because it also works on JRuby and Truffle Ruby. And you should have fun with concurrency. So don't be afraid of it, just have fun, use it, but use it wisely. And that's it. Thank you. You can find me on ivoanjo.me. I blog about Ruby stuff, and feel free to email me as well.
Thank you very much. Okay, so we pretty much tied on time. So in this case, we have a QR code. Let me pretty quickly connect it to that. And yeah, just a sec. So that's the first half of the day. As soon as the QR code will be there, feel free to use that and send questions to Ivo, or just catch him up during the lunch and ask your questions directly. So for us, don't forget to do unconference voting for the pitches. It's really close. Here is the QR code. And we want to say big thanks to our sponsors. So we have 3 sponsors from the silver level, which is JetBrains, Meister, and Secura. Thank you very much. Without you, it wouldn't happen. So let's give a little bit of applause to our sponsors. And I think that's the best gratitude, because everybody is leaving to lunch. So that's kind of what's happening there. So Euruko lunch is happening right now. And do not forget that at the same time, you guys can catch up at the lunch meetup about async Ruby. So enjoy the lunch, and I see you in 1 hour. Cool.
You got a fast car. I want a ticket to anywhere. Maybe we can make a deal. Maybe together we can get somewhere. Any place is better. Starting from zero, got nothing to lose. Maybe we'll make something. Me, myself, I got nothing to prove. You got a fast car. I got a plan to get us out of here. Been working at the convenience store. Managed to save just a little bit of money. I wanted to try too far. Just cross the border and into the...
So, Ivo, thank you very much for your talk. I have a couple of questions, brief questions. So first one is, Ruby was made to make engineers happy. How does it makes you happy?
I think out of the many things, I would say the DSL. I feel like the power to create DSLs very easily means I create when I want to solve a problem, I can create a mini language that's the language of the problem, and then I can solve the problem